Alright guys, we're going to continue learning some more derivative rules. That's what this whole unit's all about actually, with a sprinkling of a few other topics, but most of it's just derivative rules. Today we're going to learn something called the product rule and something else called the constant rule. Oops. Erase that real quick and we shall proceed. Alright, so here's the product rule. So if we have a function which we'll say is h of x here, and that is equal to a product of two other functions. So h of x is basically just taking two other functions and multiplying them together. Then the derivative of h prime of x is this weird looking expression. Okay, so that looks really ugly, so let me try to make it look a little bit simpler. Okay, so if you have a times b, if you want to take the derivative of this, and remember a and b they represent functions, okay? A and b represent functions, not numbers, but just functions, okay? So if you want to take the derivative of a product, here's how it works. You're going to write ab, ab, and put a plus between them. And then for the first set, you'll put a derivative here. And for the second set, you'll put a derivative on the b instead. And honestly, it doesn't really matter if you did this. You could have did it backwards, put the derivative on the b and then a on the other one, because when it comes to addition and multiplication, order doesn't really matter. So that's what we call the product rule. Okay, so let me give you guys a quick little example just to show you how well this thing works. So let's say that I gave you guys this. Okay, and I asked you guys to find the derivative of this. Well, there's actually two ways to do it. So first of all, I want to do something that's not the product rule. I want to ignore this for a minute. And I just want to say, well, how would we take the derivative of this? Well, what I would do first is I would just go ahead and multiply these together. What is 3x squared times 4x? Well, that would be 12x cubed, right? And then I would take the derivative of that. So that's where you're going to take 3, you're going to multiply it to the front, and then you're going to take 1 away from the power. And there's my answer. But I want to show you guys how we can do this same problem using the product rule. Now you guys might think, well, why do I need to learn that rule if we already can do it this way and it's easier? Because not all problems are this easy, and multiplying them actually turns out to be a lot harder. So I want to show you guys using an easy problem how to use the product rule. And it's going to give us the same answer actually, but it's just different in how it works. So let's do the product rule. So we start off like this, right? We have 3x squared and we have 4x. Now this is like my A, and this is like my B, right? And I told you guys it was going to look like this. AB, AB, A prime, B prime, right? So there's that. So let's go ahead and fill this in. So what's going to go in this first blank is the derivative of A. What's the derivative of this expression? What is 3x squared? What's the derivative of that? Well, if you multiply the 2 times 3, you get 6. And if you take 1 away from the power, you get 1. So it's just going to be 6x. Now what goes next to that is b. What's the b value? It's just 4x. Notice I'm not taking the derivative because it doesn't say b prime. It's just b. Next one. This blank is just a. What is a? It's 3x squared. The next one is b prime. So what's the derivative of 4x? Well, that's the multiple rule, the constant multiple rule. When you have an mx, the derivative is just the m. So in this case, the derivative of b would be 4. Now we're going to simplify this. What is 6x times 4x? That would be 24x squared. What is 3x squared times 4? That would be 12x squared. Now these are like terms, so we can add those together. What's 24 plus 12? You get the same answer that we got over here. Now, once again, you guys might be thinking, well, that was like a lot more work and it was hard. I agree. if I ever saw a problem like this, I would definitely do it this way. But the problem is not all the problems are like this. You have products where things are a little bit more complicated, and actually taking the time to multiply them together is so tedious that it's actually easier to do it this way. Okay, so that's what we call the product rule. Let's go ahead and put it to work for us here. We're going to start with a table approach. Okay, so we did tables before, so this can be a lot like that. So they tell us that let h of x be f times g. They want us to find h prime of 4. So the first thing we have to do is we need to find out what is h prime. So h prime of x is going to be blank blank plus blank blank, because this is a product, right? We have two functions being multiplied together. So if you want to take the derivative of that, then you're going to apply the product rule, where this is a, this is b. Derivative of a on one, derivative of b on the other. All right? So if a is f of x, then what's a prime? Well, that would just be f prime. B is g of x. A is f of x. B prime. What am I going to put for b prime? Well, since b is g of x, b prime would be g prime of x. Okay? So that's the first thing that you need to do, is you need to apply the product rule to find h prime of x. And the reason we're doing the product rule is because h of x is a product function. Okay, the next thing we're going to do is we're going to plug in the number that they're asking about, which is 4. So here we go. H prime of 4, which is what we're trying to find, is f prime of 4 times g of 4 plus f of 4 times g prime of 4. And from here, we're just going to use the table. Okay? So this is what I'm looking for, so I'm just going to bring that down as is. That's not in our table, but everything else is. So let's do f prime of 4. What's f prime of 4? Here's my f prime column. Here's where x equals 4. So f prime of 4 is negative 2. What's g of 4? Here's my g column. Here's 4. So g of 4 is going to be 3. Next one, f of 4. Here's my f column. Here's 4. Answer is 2. And then finally, g prime of 4. Here's my g prime. Here's my 4. It's 2. And now we just have to simplify what's left. So negative 2 times 3 is negative 6, plus 2 times 2, which is 4, comes out to be negative 2 as my final answer. Okay, so that's what we call the product rule and doing it with a table. Okay? All right. So here's a student practice for you guys. Go ahead and give it a shot. See what you guys can do. Pause the video here, and when you unpause it, you will have the worked out solution to see how you did. Okay, and there's your solution, you guys. We have the product rule here. We plugged it in. I used the table. And there's my answer. In years past, I've had students get the wrong answer, not because they did the math wrong, but because they didn't realize this table is different than the table in the last slide. So I don't know if you were using the table that was on your notes or if you were using the table that's actually on the screen here, but they are different. So if you didn't do the correct table, it might be good to try it again just to make sure you got the idea, but you should end up with 5. Okay? So that's the product rule. Let's go ahead and continue here. Now I'm going to show you guys how to apply the product rule to something that, instead of having symbols, because like for instance over here, we don't know what h and f and g are. They're just these invisible functions. We know what their certain values are for 1, 2, 3, and 4, but we don't actually know what the functions are. So we're just working with symbols. But in this problem, we actually know what our functions are. So y is kind of like my h. This thing, x squared minus 3x plus 1, that's going to be my f of x. And this one over here is going to be like my g of x. But as you guys can see, it's still a product function. We still are going to apply the product rule to find the derivative. Okay? So, here we go. So to find dy dx, which is just another way of writing the derivative, we're going to have blank, blank, plus blank, blank, right? A, B, prime the A, prime the B. Okay, so I'm going to call this F. I'm using two different forms of notation. You don't really need that. I was just demonstrating something. So this first part I'm going to call the A, right? So what is the derivative of this piece right here? Well, now to take the derivative of that, you got to take the derivative of each piece separately using the sum rule. So the derivative of x squared is 2x. The derivative of negative 3x is negative 3. The derivative of 1 is 0, so we don't need to put it. So there's the derivative of A. Next, we're going to do B. But notice that this is just regular B, it's not B prime. So all we're going to do is we're going to put that there. Okay? Next, we're going to put A again. So this time it's just normal A. So in other words, we're not going to take its derivative. We're just going to write it exactly as it appears. And then we're going to put B prime. I should say prime there. So now we're going to do the derivative of B. The derivative of B would be the derivative of that plus the derivative of that. So the derivative of x cubed is 3x squared. And the derivative of 4x squared is 8x. Okay. And that's where we're going to go ahead and stop. We're not going to go any further than that. And that's our answer. Now that looks really ugly, but that's our answer. Clean this up a little bit. Now, that, believe it or not, that's a lot easier to do than me asking you guys to multiply this out using the FOIL method and then take the derivative. Technically you could, but it's just a lot more work. So this is an example of where, yes, it's actually easier sometimes to do the product rule. The answer looks really ugly, but it was easier to get that answer than it would have been to have done it the other way. All right, let's go ahead and do number 2. Number 2 is asking us to find dy dx at x equals 1. So I've already found dy dx, so now it's just asking me to plug in 1, right? So all we're going to do is we're going to plug 1 in for x to what we did in the first part there. So let's plug in 1 here. And here. And here. And finally here. All right, let's simplify this. What's 2 times 1 take away 3? Well, that's negative 1. 1 cubed plus 4 times 1 squared. Okay, so 1 cubed is 1. Over here you have to do the 1 squared first, so that's 1 times 4 is 4. So I have 1 plus 4, which is 5. Here, 1 minus 3 plus 1 is minus 3. And then lastly, we have 3 plus 8, which is going to be 11. And we end up with negative 5 plus a negative 33 If I put those together, my final answer will be negative 38. So now let's talk about what we just did. Okay, so I have a function, and that function is called y. And y is defined as being the product of two other functions. In part 1, I found the derivative, which is a formula that tells me the slope of this function at any given point. In part 2, I asked you to find the slope of this function at the point x equals 1. So for the function y, when x equals 1, the slope at that point, the instantaneous rate of change, would be negative 38. That's a very steep negative slope. Okay? But that's what we just did there. We found the derivative and we plugged in a point. So I want you guys try one of these problems now. Student practice. Go ahead and pause the video here and see if you guys can get the answers to 1 and 2. All right, so here's your answer for number 1. This is the derivative of the function. And then I went ahead and, for number 2, finding the instantaneous rate of change of y with respect to x when x equals negative 1. That's just the verbal way of saying this. Okay, and so once again, we're just going to be plugging in negative 1 in everywhere. So if I plugged in negative 1 here, I got negative 12. If I plugged in negative 1 here, I got negative 1. Now, some of you guys might be having a hard time with that. So what I want you guys to understand is when you're simplifying these, you do the power first. So for instance, if you're plugging in negative 1, let me work this. I'll work out this one piece just to demonstrate it. But like here, negative 1 to the 4th power is going to be a positive 1. Whereas negative 1 to the 3rd power is a negative 1. And so we end up with 2 minus 5 plus 2, which is going to be negative 1 when you put all those together. So that's how you simplify. Exponents first, and then multiply, and then add and subtract. Don't forget, even powers cancel out the negatives. Odd powers do not. Okay. Anyway, continuing to plug in 1 here gives you 8 and 7. And then multiplying and adding, I got 68. So, and by the way, it's possible I make little calculation errors as I go, you guys. So you can ask me about those when we have our FaceTime, or you can post a question to the video in the notes if you want to. I try not to make errors, of course, but I do. So if you ever see that I did something wrong or multiplied wrong, you can just post a note to the video. I think that would be really helpful to your peers, or you can just bring it up during our FaceTime. All right, let's go ahead and talk about the constant multiple rule now. Now, we already did that earlier. It was this, right? And I told you guys that the derivative of that is just going to be m, right? So, for instance, if I told you guys that y equals 5x, then y prime is 5. Okay? So we've already done the constant multiple rule. But I'm going to make it a little more complicated. Instead of saying y equals mx, I'm going to say y equals m f of x. So in other words, it's not just an x here anymore, it's an entire function. All right? So the way that this works then is going to work like this. The m's going to stay there, just like usual when you take the derivative. But since there's actually a function here, not just an x, you're going to put f prime there now. Okay? And that's what this rule is stating. So if f of x is a function which is defined by another function being multiplied by some constant number, like 2, 3, 4, 5, half, whatever, then the derivative of f is the same thing as the derivative of g being multiplied by that constant. Okay? So, now, when you guys start to feel overwhelmed, I just want to remind you, you want to be making flashcards of all of these little rules and reviewing them. I actually put in your guys' notes that you're going to pick up from the school in the very back, I made flashcards for the entire year. But until you guys get those, you can start making your own flashcards for these rules and getting used to them. If just the rules themselves aren't helpful, then go ahead and put some examples on it. Do whatever it takes to help you learn it, memorize it, get used to it, and comfortable. All right, let's go ahead and take a look at an example where we use the constant multiple rule. So this is an interesting type of question here. I've seen questions like this on the AP exam, so this could be helpful to you. Suppose that I tell you this. Now, first of all, let's interpret that. What is that telling us? Well, it tells us that we have a function m, right? And we've done something to it. What have we done to it? Well, we've taken the derivative of that function. Okay? Now, after we have the derivative, it seems like we've plugged in 3 for x. And out of it, we got 8. So here's what this little statement means in English. In English, instead of math speak, what I boxed here, what that is telling us is it's telling us that the instantaneous rate of change, that comes from the derivative here, the instantaneous rate of change of m, that's my function, when x equals -3 is 8. Or another way you could say it is, instead of the instantaneous rate of change of m when x equals -3 is 8, you could say the slope of m when x equals -3 is 8. So what this is a math expression that's telling you the slope of the function m at x equals -3. And that slope is 8. All right? So pause the video here and see if you can. You don't have to write anything down. You can if you want to. But how would you interpret that one? M prime of 6 equals 1. Well, hopefully you guys know then that just based on the last example, that means that the instantaneous rate of change, aka slope, of m when x equals 6 is 1. So basically, I've given you 2 pieces of information about this function m. I've told you what its slope is at x equals -3, and I've told you what its slope is at x equals 6. Okay? So, now let's go ahead and jump down to the actual exercise. Now, this we're being asked to find, and let's do number 1. I'm telling you now that we have a new function, h of p. It's not m anymore. We're talking about a new function called h. Now, for h is actually the same thing as m. They're the same function, with one little difference. M is being multiplied by 6 now. So h is 6 times the m function. Now the problem is asking me to find h prime of 3. All right, so let me back up really quick and let's refresh our minds. We just learned about the constant multiple rule. I told you guys that if f of x is equal to c times g of x, then f prime of x is equal to c times g prime of x, right? So we're going to apply the constant multiple rule here because I have a function that is defined as a function with a constant multiple in front of it. So to find h prime of 3, the first thing I'm going to do is I'm going to find what is h prime of p. Well, according to the constant multiple rule, the 6 stays right where it is, and then we take the derivative of m, which is m prime of p. Now the problem's asking me to plug in -3. So, that should look familiar to you guys. What does m prime of 3 equal? M prime of 3 is 8. So I can just replace this, m prime of 3, with 8, and now I get 48 as my answer. Okay? So since h of p is equal to 6 times m of p, then the slope of h is 6 times greater than the slope of m. And since the slope of m at x equals 3 is 8, then the slope of h at x equals 3 is 6 times greater than that, which is 48. Okay? Well, let's do another example. If I were in class, I would ask you guys questions and I'd let you answer me to lead me through this. So I'm still going to ask questions and you guys can kind of think of the answers in your head here as I ask them. So now I'm giving you a new function, y. How do we know that that's a constant multiple function? We know that we're going to use the constant multiple rule to find the derivative because we have a function with a number in front of it. Just a number. No variables, just a number. That's the constant multiple rule. So when they're asking me to find dy dp at p equals 6, I know I need to start by finding the derivative of y with respect to p. How do we do that? Well, that's going to be, you guys go ahead and fill in the blank. What is the derivative of y? If y is equal to 2 times m, then what's the derivative of y? The derivative of y would be 2 times the derivative of n. Now they want me to go one more step and actually plug in 6. Okay, so now what do? We're not quite done yet. We do something with this. We can replace it with 1, because up here we know that m prime of 6 is 1. And the final answer would be 2. Okay, so there was 2 things that we did on this slide. One was I was showing you another way the question could be asked. You know, we've done tables, we've done equations, but this is another way the question can be asked. It's like they give you some information up front, and then you have to find the answer and then use the information the right way to get the answer completed. It's a lot like the table question, actually. It's just written out a little bit differently. So that's one new thing. The other thing is we're actually applying that constant multiple rule. So we've talked about 2 rules today. We've talked about the constant multiple rule, which is a function being multiplied by a number. And we've also talked about the product rule, which is 2 functions being multiplied together. Okay? The difference is that the product rule, you actually have 2 whole functions there, whereas with the product rule, you're just multiplying one function by a single number instead of another whole function. So here is an example, a student practice for you guys to try to match the one I did with you in the last slide. So go ahead and try this, pause the video, and when you unpause it, you will see the solutions. Okay, and there is your solutions for this particular practice set. All right, and that closed out that lesson for today. So go ahead and do your 1.3 homework, and when you're done, you can move on to the next lesson if you like.